Hi. Starting today, we'll be diving into important backend concepts. It won't be a concept dump. I'll try to make them as intuitive as possible, break down the concepts, and understand them in a way that actually matters for the industry standards. So, we'll be initially breaking down the invisible nervous system of 15 trillion digital economy. So, in other words, it is API. So, API stands for Application Programming Interface. I don't want to bore you guys with the definitions. So, API is the architect. In other words, you can call it the architect's blueprint for universal connectivity. All right, let's dive in. Let's say you are the user and you have a mobile phone in front of you. If you want to book the Uber ride, all you just do is click on book ride button, select your source, select your destination, and then click book now. So once you do that, all you see is that there might be like 3 to 4 seconds of delay, and after that, a ride will be delayed. Confirm, right? So you don't understand what's happening in between those two events. All you care is that I click on the button book now, and all I see is the ride getting confirmed. So those are the things that only matter to me, right? But in the backend, in the span of time when you have clicked, tapped book now, and the ride getting confirmed, there might be so many events that might be happening. So for instance, in this scenario, initially there might be a service like Auto that might identify the actual user, like if it is a valid user who has clicked book now. And there might be some other service like Stripe, they might process your payment. And there might be other service like Google Maps that might retrieve your location as well as the nearby driver's location. And there will be a driver dispatch logic. So once that is done, so once you have source and destination, so all the drivers that are in between them will get notified, and the one that clicked confirm will be dispatched, right? So that is how it works. And finally, you can also use other service like SendGrid to basically send the receipt once the driver gets dispatched. Cool. Talking about the API, they act as like connective tissue for the global economy. So they allow all these distinct software systems to communicate. For instance, we have seen that while booking a Uber ride, so Uber internally talks to some other payments service like Stripe, and you can also talk to Google Maps. And after this is done, they send their respective responses, and that's when you see those changes on the app, right? So all these things, company A talking to company B or C, is happening via API. If actually the API breaks, the world actually stops. So banks can't process payments, planes won't land, and the phone, it becomes isolated brick, right? There's no use, like you tap on some button and nothing happens. All right. Now let's understand the conceptual model, the restaurant. Imagine a restaurant, you're the client. Basically, you're the customer. It could be something like your mobile app. And the kitchen, this is basically the server. And it has all the database and logic and all the information stored in it. You need to access those resources from the kitchen, but you can't just go walk in there and start cooking, right? Imagine there are multiple customers, clients, then basically all those shouldn't be allowed to enter into the kitchen and do whatever they want. They will turn this into messy, so which is not what we want. So direct access is basically chaotic, and it's also insecure, right? What if this guy goes there and steals things? It's not good. That's where the protocol comes into picture. So meet the waiter. This guy, let's focus on this guy for now. This guy is the waiter. He accesses actually the API that we are talking about. So now this customer, he's basically the client, like a mobile phone or UI where you can place orders from. And this is our usual kitchen, this server, which has all the resources. And this menu card, whatever the waiter is holding, that is the API documentation. The waiter is actually the API. So how it actually works? Step one is that the waiter acts as the API, right? So the step one is that you give the waiter your order. So this client will basically orders some food. Then the transport happens. The waiter takes your order and then he goes onto the server and tells him what the order is. Then the kitchen then responds back, like basically the chef, he cooks food, whatever you have ordered, and gives you a status, right? So that's when the waiter returns your food, the actual data, right? And let's talk about the power of abstraction. So initially, as a customer, you just send one request. You don't know what's happening inside that. It's all this messy loop, right? And at the end of the day, some things get processed and you'll get clean result. So that is the response. As a customer, you basically don't know how the stuff is calibrated, right? How to chop an oil. You don't care about that. All you care about is basically the result that you're getting. So APIs basically provide these abstractions. This underlying logic is hidden. We don't know what's happening inside this. This is typically a black box. And the idea is that this server says, the API says, hey, tell me what you want. And I'll hide all the messy database logic required to get it. And at the end of the day, I'll give you what you wanted. Cool. Now let's go a little bit under the hood and see what this request and response lifecycle is. So the waiter, this is how this guy looks like to the server, right? So this waiter gets your order, talks to the chef. So in the machine language, this is how it looks like. All this data, the order that you gave, will be represented in binary form. or some kind of notation, and the machine has that data in either binary format or machine readable format, and it understands that. That's where it processes it and gives you the information. So it is a conversation in text, usually formatted as JSON, also known as JavaScript object notation. We will see how this looks like, but yeah, I think most of you must be familiar with JSON notation. And this is what a typical API looks like. So this is one type called API. So you could say something like, this is the amount, and this is the currency, and this is the source, and this is the description. So the instruction tells you like what the server does, and these are the key value pairs, the basic information like what it denotes. And see that these are actually noticeable to both humans and machines. The contract. Now let's talk something which is really important. So the API is ultimately a contract. It's between two systems. Let's say there is a company A and there is a company B. There might be mutual contract between both of these, like how these ask questions and how they respond. So ultimately, at the end of the day, this is all that matters. The promise is that the API says, according to API contract, says that, hey, if you give me X in valid request, I promise to give back you Y, that is valid response. This is the contract. And there's a guarantee, like there is no unpredictability. The developers are assured that if you give X, like if you request X, you're bound to get Y. So the predictability allows these developers to build massive, applications on top of other people's software without fear of changing it rapidly or randomly. The contract that you actually got initially withstands. If you ask a particular request in some kind of format, at the end of the day, you'll get what you're anticipating. Either it fails completely due to some issues, or you'll get the response that you're anticipating. Cool. Now, since we got like clear picture of what API is, now let's understand the real world constraints. It's not just about writing, request and response. In actual real world, these metrics define the quality of your API. For instance, the first one is latency. So latency is basically how fast the way to return. In other words, after you send your request, how much time does it take for the server to get back with a response? That is what the latency is. And coming to the second thing, rate limiting. So how many requests before the server cuts you off? Imagine this is really important. So for the rate limiting, imagine you are a small business and this is your server, like kitchen, right? And there are so many people placing orders. Let's say one of the user continuously is calling you and placing the orders, right? It is very inefficient. How many orders can the kitchen actually serve? It easily gets bombarded by all of these orders, right? And it might easily go offline. So we don't want that. And the other thing is uptime. Like basically how much time your kitchen is up and running. When you place orders, you don't want the orders to be rejected. So it needs to be up and running. In other words, I wouldn't say this is reliability. I would say this is more like availability. How much time your kitchen is available to serve the orders. Now let us understand this in more practical way. For humans, we only see this interface. That is what it matters to us. For example, you can use any app out there, right? You can use request write. All that matters is that when you click request write, the write will be booked. But machines don't understand that. Machine needs some kind of format. Remember, we talked about JSON, JavaScript object notation. This is how it looks like, right? So basically, you have all these in key value pairs. And if this is not the case, just imagine when you click on this request write, let's say as a user, you get a JavaScript object notation, and then you need to edit all the details manually, like you sending, hey, this is the source I am at, this is the destination I am at, I need to enter these details, and this is the fare that I'm charging. So this is all hectic, right? It takes a lot of time and it's not user convenient. The whole idea is that UI, it is designed for humans, like actual users. And API, it is developed for machines and for developers, right? The focus is basically the efficiency, how better your APIs are. Cool. And coming to the types of different APIs, there are actually two types. One is public and the other one are internal APIs. I guess most of you have like used APIs, right? So you could have used like Twitter APIs or Google Maps on a personal projects. So all these are public faced. So basically they'll have some sort of rate limiting implemented and you can't exceed that rate limit. So you can use them for free and explore what they provide. And then you can basically play around with them. So those are what the public APIs are. But under the hood, there are like multiple internal APIs. This is the bulk part. This is how company A talks to company B, right? So these are internal plumbing of private organizations. That is how they have trust between one company A to company B, and the APIs make sure that whatever the company A is requesting to company B responds with something that company A is anticipating. Remember, that is what the API contract is. Cool. And since I hope you got a fair idea of what API is. Now the key thing is like, how did they actually communicate with each other? So in the upcoming videos, I'll be jumping into, in fact, in the next video itself, I'll be jumping into difference between REST and GraphQL and what is their role in API development. Cool. You now see the blueprint, like you have been active observer. You just understood, like as a summary, as a user, all that matters is that when you click on this button, book write, a ride will be booked. And that is what it matters, honestly, right? But under the hood, there may be a lot of things that are happening which we don't even notice. So I hope you got fair understanding of what transaction is, right? From clicking book ride to ride getting booked. So what happens under the hood? It all happens, right? API, the application programming interface. And you also understood the protocol, the waiter and contract, right? So basically, if you give me X, if you request me X, I promise to give you back Y. That is what the API contract is. And you also understood the code. Remember, UI is for humans, like basically users, and JSON object, which looks like this. It's some key and value pairs. This is more for machine. All right. So finally, moving on. Tomorrow we'll be discussing about REST API as well as GraphQL. Stay tuned. And yeah, I would really appreciate if you guys tell me in the comments. I would really appreciate if you guys tell me in the concept like what was the most confusing API documentation you have ever read. This is more like the menu the waiter has, right? So what API documentations have you read and what were the challenging things about that? Cool. See you guys in the next video. Take care for now.